Hello guys, welcome back. In this video, let's talk about Quadrant. So what is Quadrant? It is a vector similarity search engine, right? There are many vector databases out there, but why Quadrant might be the question also, because there are many news recently that Quadrant is being used in big corporations. One is the one that is the point, and the next one is they have some fundings, meaning that somebody believed on them and they are creating some good contents. And also there are many partnerships news here and there. So why not learn a new database or vector similarity search engine that is being popular these days, right? So how the video will proceed is 3 steps. First, I will show you how you can run these locally, get the Python client, and the next one using the Docker. So you will also have you can see the UI in the localhost itself. And the third one is how to spin up a Quadrant cloud so that you can just use with the API keys. If you want to know more things, I will provide the link in the description. More things in the website itself. There are good examples, guides, and so on. But yeah, these are the things I will be showing. So yeah, let's get started. Okay, so this is the notebook that I'm going to run in this particular video. I will provide this in my GitHub repository, and I will provide the link in the description. So please feel free to go to this GitHub repository and clone it yourself so that you can run it along with me. So there are 3 ways to use the Quadrant, as I said you before also, and the recommended workflow is also that you can try first from the local Python, and then you can use the Docker, and then use the cloud to deploy the things. So try, develop, and deploy. This is the recommended workflow, but of course it depends which one you want to use directly. So as I said you also before, Quadrant is the vector similarity search engine. So how to install first? So yeah, just pip install things. I will run this command first and then explain you what I'm going to do. Okay, Python virtual, I think I didn't okay, I need to first activate the virtual environment. Okay, once the virtual environment is being activated, and you can see that I'm going to install Quadrant client, LangChain, watermark, and sentence transformers, because I'm going to use the Hugging Face embedding model. And then there is this unstructured for loading the documents, right? So yeah, this watermark is just to show the different versions and which machine I'm using, because most of you always ask me, okay, what is your machine, in which machine are you running, and something like that. So just install the watermark and just provide random code or snippet, whatever you want to call this, or command, and it will show you which Python version, IPython version, which version of LangChain, what's the compiler, OS, release machine, all the different things, right? So yeah, now we have our packages installed. So next what we can do is we want to use the Hugging Face embeddings and LLMs from Grok. Get Grok API key from this link. So I have provided the link which points you to the Grok's website. As you can see here, I have already created the API key. If you are new to Grok, I have already created, not Grok but Grog, right? I have already created videos related to this. Please refer to that if you are new. Otherwise, just go to this URL, get the API key. It's free for now. You can just try it, right? So yeah, I'm just importing some import warnings because there were some warnings when I was running this. So yeah, now what you can do is just from LangChain community.embeddings import the Hugging Face embeddings, and we are going to use this model, right? So I will run this one. So it is going to download from the Hugging Face hub. So it will show you some installation steps here, right? So once that is done, we can just go here and see what are the different parameters of that embedding model. So it is now installing, so I can already run this embedding part. So this is the good part of notebooks, that you can run in one cell some of the things. In the next one you can see what it is, right? So if you just want to see what is this all MP net base v2, you can just see here embedding. This is the client sentence transformer, and max sequence length is 384. Do lower base false with transformer model, and it is using MP net model. You can see all the different things if you want. And the good part of this, or the good part of Hugging Face embeddings, is you can switch different models as you want from the Hugging Face website. I have shown you different ways of running the embedding. So this is another way of running the embedding models for free, so you don't need to pay for some third-party providers. And now we have our embedding model. And now what I'm doing here is directory loader, because I want to load from the document from the directory. and I'm saying okay, import the quadrant and the recursive character text splitter, right? So I will just run this one, so it is imported. So once that is done, as you can see here, now I'm saying loader and directory loader and data, all the MD files. So this is the simple loading all the documents that is inside the directory data, and I just want to read all the MD files, right? And what is in the MD files, I will just show you here. And inside the data folder, I'm taking this Uber 10K March 2022.md file, which is the cleaned version of the PDF file which I used in the Llama Parse video. So if you want to know how I did that, please refer to the Llama Parse video, but it is the cleaned version of the PDF file, so we can load directly for practicing this quadrant, right? So yeah, just run this, and what it is doing is loading all the data from this, and it is doing the recursive text splitter. I'm just providing 1040. It's up to you which you want to provide, and then pass that document into this. So you can see that there is already the documents being provided. So if you just want to see how many documents it provides, just do length and then the docs. There are 283 documents inside that, right? Documents, or let's say the different docs from that documents. So yeah, this is the connectivity quadrant from LangChain. So this is the normal flow. As you can see here, there is the user, how many is this, there is a question that goes to the LangChain, there is question embedding model, get the question vector, and it goes into the quadrant question vector, top k facts is being retrieved into the LangChain, and then you can see prompt with top k facts goes to the LLM gets the answer, and that answer is passed into the user. So this is the normal RAG flow, right? And now let's go with the local model. There are three modes, as I said you. Let's say with the local mode. So here, yeah, there is the in memory and there is on disk storage also. So if you don't want to store, you can just use the in memory. So there is the quadrant.from documents. We were passing the documents, right? There are 283. There is embeddings that we use the Hugging Face embeddings. Location memory, meaning that local mode with in-memory storage, right? And then the collection name, I'm just giving in-memory collection name. So yeah, if I run this, then now I have all the embeddings stored in my quadrant in memory, right? So this is how you can do with in memory. But if you want to store this somewhere so that you can reuse it next time, just provide the path here instead of location memory. Just provide dot slash, and if you run this, it is going to be stored. Now if I go to my local folder, so I'm inside here, right? You can see I am in this folder, and there is this collection being created by default. And if you go inside, you can see there is this storage.sqlite being created, right? So that is how in memory and storing in the on disk storage works. So yeah, that is the simple thing. Now how to do the similarity sorts, right? I will say here what is the net loss value attributable to Uber compared to the last year. So this is just a query that I want to ask from that particular markdown file, right? And then I can do quadrant.similarity sorts and then pass the query. So if I do this, as you can see here, it shows us the answer. So this is what it is getting, because all that is in the markdown, so it just gets that answer here, right? But if you want to go and see how many found documents are there, what you can do is just maybe let's go here and let's do length of found docs. So it will be 4, because we are taking the top 4. So top k is 4 in this case. So that is the by default being used. So you can play around with this also. So yeah, you can also do similarity sorts with scores. For that, what you can do is there is another method, a quadrant or function, right? Quadrant or similarity function, similarity sorts with score. So before it was just similarity sorts, and now there is similarity sorts with score. So you can just play around with this and see, okay, what is the similarity sort? So this is 0.7938, right, for 0, and then we are taking the first one here. So if you just want to know the second one, just go with 1. Okay, 1. If I do 1, here is now 7938, but let's see the second one, maybe it's more similar. Okay, it's 76, so it's even less. So yeah, you can just play around with this, which one is the best. So if you go to 2 it is 76, right? And let me go with the last one, where it is here. Let me go with 3. What is it? So it is 75.6. So all of them are in the range of 0.75, 76, something like that. So you can just play around with this, which one is the best, and then you can also print, okay, what it is getting from that particular chunk, right? So yeah, that is about the local mode. Now let's go with the on-premise server deployment. For this, as I am showing you to the particular URL also here, this is the quadrant.tech. So this is the main website vector database, and it says here docker pull and then the docker run command, meaning that you need to have a docker installed first in your machine. So now what I need to do is I will open the terminal. So here I will first open a docker, right? First install the docker. So I have already installed, and with this command you can run in the Mac. So now my docker is being opened. I will show you, and I have already pulled the quadrant docker. So if I will just bring this, as you can see here, there is this quadrant, and if I go to the image, there is already this quadrant, right? So if I go to the container, so I will just go ahead and do start, and now it is listening in the port 6333. So if I click this one, so as you can see here, it shows that, okay, quadrant vector search engine version this, right? So this is running. Now what we can do is we can run this now, localhost 36333 as the URL localhost. So I hope you are getting what I'm showing here, because first one we didn't have any URLs, it is just in memory, and it's somehow similar to, let's say, Chroma and Fios, which I used to show before, right? It is just the in memory, or you can save into the disk. But now this one is with the Docker, which will also have, let's say, URL, so that we can see what it is being stored in that particular container. So yeah, quadrant docker, this is just a different name I'm giving here, and the syntax is almost the same, as you can see here, except we are passing the URL and collection name, and we are passing this prefer grpc equals to false, right? So yeah, let's run this. Now once I run that, it will be creating the collection now. So yeah, now if you want to see the collection, what you can do is just click this URL, right? Just click this URL, and in the URL what you need to pass is on the slash, you can say dashboard, right? So if you run this, yeah, there is a new dashboard being shown, and you can see we have this server documents which we provided the name. So if you go inside this, and we can see all the different chunks with the metadata that is being attached in this. So in the first one we were not able to see this dashboard, but now you can see the dashboards, you can see the info, snapshots, visualize the things, and all the different things that you can see. There is the console also, from where you can do many things. There is the collection, there is the tutorials if you want to see, there is step-by-step things here, right? And there is the data sets also already being provided for us. So this is a good looking, let's say, UI, where you can just see, okay, what is my chunks that are being stored in this collection in this quadrant. So this is really good concept, because you can have let's say the cloud way already in the local machine, right? So I really like this way. And now all the things are the same. From here you can just run the same commands and find the similar things. So that is two things. One is the local mode, and the next one with the Docker, where you can see all the things, right? And the next one is similar to what I just showed you in the UI, right? But this one you don't need to set up anything. Everything is done for us, and we just need to have the API key and the quadrant URL. For that, what you need to do is I provided all the links here. So this is the quadrant cloud. Just click on this one, and it will take us to the cloud. Here I have already created the account. If you haven't, you need to create the account, and then there is a cluster that you need to create. And if you click on this, there is the URL. So you just copy this URL, paste into here, right, where I have been pasting the URL. And if you want to get when you create the cluster, there is a way where you can create the API keys, and just take the API keys and just paste it here, right? So let me go here. I'm just pasting the API key and the URL here. So I will just run this this part. So yeah, that's the thing that you need to do when you want to use the quadrant cloud. So yeah, other things, as I said you again, it's all the same commands. This is really good because the way how you do it, local mode, or then this storing persistent storage, using it with Docker, using with BitCloud, all the syntax are, if you just want to practice, is almost the same. Just URLs, just providing let's say embeddings, API key, and so on, and giving the different collection names, right? So yeah, now that is done, I can just go here and ask same query here, and just it's getting the same answer from here. And then also the collection is going to be reused if it is already existing. So this, I think this is what I think someone of you also asked me in my previous videos where I was using the quadrant. So the collection is going to be reused if it already exists, right? Setting force recreate to true allows to remove the old collection and start from the scratch. So now I am saying here force recreate equals to true. So if I do this, then what happens is the previous one will get deleted and it will be created again. So it will take some time. So if you go to the let me go to the URL here, right? If I run this again, and if you want to see from the cloud also where is your dashboard, right? In the cluster, if you click this one, and there is this open dashboard things, right? So this is the same dashboard now you are seeing, which we used to see on our local machine. And for the first time it's saying API key because you need to provide the API key. For now I will just use the API key that I provided here. So this is the API key. I will be deleting all these API keys later. So I will just copy this and go to my cloud. I will paste it here, apply, and now there is two different things because this was the one I created before, and now there is Quadrant Cloud Documents. So all the things again, it's UI is the replica of what we just see in our local machine. So that's simple, and we can use different ways, right? So yeah, let me again go to the code now. So yeah, that is all the things. And if you want to see the similarity I showed here, if you want to see again with the scores also, you can do. But now we did play with the quadrant, and we know how to find the similarity. Now how to plug this now into, let's say, LangChain expression language and with the model from the Grok, right? Meaning that you can now have that top k things, ask some question, and from that top k we get a human readable answer when we ask the questions, right? So for that, what we need to do is we need to install the LangChain Grok. I will install this, right? And once that is installed, you need to go and get the API key, and the link is, I provide the link I think somewhere on the top of the website. So there is this Grok API key. Just go to this link. As I said you before also, I have created many videos before also. Please watch that if you are new to the Grok, and get the API keys. And now I have already the API key here. I will just use the API key. And yeah, these are the normal import things that you need to do from the LangChain. So there is the chat Grok, string output parser, chat prompt template, and runnable pass. And now here is the retriever, right? Now the good part here, as I said you before also, so this is the Quadrant Cloud dot as retriever. I'm retrieving from the Quadrant Cloud, right? But you can just use different variables for different like for local, for Docker, or anything like that. With just one code change, you can play around with different things. So now I'm just saying, okay, from Quadrant Cloud, retrieve everything from there. So it is stored in the retriever. And then I have this template. Okay, answer the questions based only on the following context. I am passing the context and the question, right? And now I'm creating the prompt. So chat prompt template from template, and I'm passing the template. That's it. And then there is the chat model. I'm taking the chat Grok. Temperature is 0. Model, I'm using the Mixtral, this thing. So I will just run this, and it is saying, okay, Grok API key, type value URL. Okay, please add an environment variable Grok API key. So I have this Grok API key here. I run this, and okay, maybe what it is asking here is I need to pass the API key equals to, so I have this Grok API key, and I can run this. So that was the error. It is saying, okay, pass the API key into the chat grok, right? So now we create a chain. This is so good that the LangChain expression language, it's a readable and simple code, right? We created all the variables here. Now what we do, there is a chain, right? And the context is our retriever, right? We want to take the retriever, top how many you want, top 5, top 10, anything. We want that to be as a retriever or a context, right? And we have the question, and we are passing that into the runnable pass-through. And there is the prompt, and we are piping that with different things. Okay, first go with the prompt, then go with the chat model, and then the string output parser. So yeah, this is the code that we created chain. Now what we do is chain.invoke the query. We have the query already being defined, right? Before, what we used to do is we are taking the retriever only from that query, but now with the help of this chain, we can get the answer from that query. So for this, just to have the good display, I'm importing IPython display, markdown, and display, right? I will just run this one now. So it will provide us the answer. As you can see here, this is just a random error. We can just ignore this for now. The net loss attributable for the 3 months in date March 31 2022 is 5.930 million, and all the different answer is being provided. So yeah, you can see now we have 1 sentence, 2 sentence precise answer instead of those retrieved documents. And now, as I said you in the beginning also, Quadrant is everywhere. Big companies are using Quadrant. Why not we just go through this, and I'm just showing you a high level picture how to use this with the LangChain framework, but you can just play around with LlamaIndex or other different frameworks, or purely use just Quadrant and do different. So yeah, now I hope you get the idea, and then just try with different vector databases. Which one performs the best in your use case, because different vector databases has their unique way of creating the embeddings. Some of the not embeddings, but storing the embeddings, not creating, right? Storing the embeddings. Some have different metadata, so that you can add additional things into the vector database, and the indexing is also different for different, so that you can sort that particular index. Now I just showed you one example where there were 283 some chunks. In the production level code, there will be millions of those different chunks, and then millions of indexes might help you to get the answer as fast as possible. So yeah, just give a try. Let me know in the comment section if you face any issue or not. If not, then yeah, that's good, and just give a try. Thank you for watching, and see you in the next video.